Hi, this is Mrs. Baxter, and today we are going to talk about radical expressions and do a lot of practice. So what I'd like you to do is, first of all, if you are not sure what a radical is or that you're not familiar with this and want to do a little bit more of a review, you can go ahead and watch the Math Antics video to kind of see a little bit more information about that. Otherwise, we can just jump right in here. So when we're looking at radical expressions, I'm talking about the square root sign. So as I come in here, this sign right here is what we're talking about, right here. This is a square root sign, or it's also called a radical, okay, or a radicand. Usually this can also be put here like this. It means squared. And when I'm looking for squared, I'm looking for two things that multiply together, they get 49. If you were to look at your multiplication table, you would see that 7 times 7 is equal to 49. And so we have two different numbers here. So I'm going to go 7 times 7, which is really the square root of 7 times the square root of 7. So we can break those apart and do square root of 7 times the square root of 7, which really is the same as 7. All right, so what I like to tell everybody is that we're looking for partners in crime. Okay, so when I go ahead and do this, you're going to start to see me do this. When I see partners, imagine, if you will, that this right here represents a jail. You know, usually we have like a house kind of thing, but for whatever reason, this is our jail. Okay, in order to break out of jail and just be out here as a number and be free, we have to have a buddy to escape. So you're always looking for two different numbers two of the same numbers that can break out together and become one. All right, now the one thing you're going to notice about 49 is that it's a perfect square, meaning that I have two numbers that are exactly the same and it works out to just a number. Okay, you are going to notice the same thing for all 1 through 6. They are perfect squares. So let's look at 36. If you were to look at your factor tree and split this out, what two numbers are the same that multiply to get 36? Well, it's a perfect square, 6 times 6. Look at that. I have a buddy. It can come outside of jail. So the square root of 36 is just 6. All right, so go ahead and pause your video, or pause this video, and then you can go ahead and try to find your perfect squares. When you finished 3, 4, 5, and 6, come back and check your answers and see if you got the same thing that I did. These are good perfect squares to memorize and just know, because sometimes you'll see them when we start doing more difficult ones and can easily pull them out. All right, so pause the video quick, see if you can use your factor tree to find your perfect squares. Okay, so hopefully you got 10, because 10 times 10 is 100. 8 times 8 is 64. 5 times 5 is 25. And 9 times 9 is 81. So those are the really quick answers for that warm-up. All right, when we're simplifying radicals, you are going to make a prime factor tree. Okay, so that's where we break things down to the very smallest prime factor in terms of numbers. Okay, a number can be pulled outside of the square root when there is a pair or perfect square. For example, 3 times 3 is a perfect square. Okay. Now, a number has to stay under the square root sign when there is not, when there is not a pair. Okay. So what is a prime number, you might be asking? Well, a prime number is any number that can only be divided by 1 or itself. So if you looked at your factor cheat sheet, a prime number, let's look at a couple, would be 1. 2 can also only be divided by 1 and 2. 3 can also be a number that's divided by 3 and 1. 5, 7. Now, 9 is not 1 because 9 is 3 times 3, but 11 would be a prime factor. 13 is a prime factor. Let's see, 17, 19, and so on, okay? So memorize what some of those numbers are because you won't be able to divide anything evenly out of these numbers, okay? All right, if you have a question about that, let me know. So when we're actually simplifying a square root, we use some conventions that are similar, and we're going to follow the same strategy every single time. So you're going to create a factor tree, right? And we're going to look for pairs. Anything that's not a pair stays under the radical sign. Okay, so let's do 24 together. All right, 24, what can we divide that by? Well, a lot of times, just as a hint, if I didn't have my factor tree, I'm going to look at this number in the ones column. If it's an even number, I'm going to divide it by 2. That's an easy start, okay? So in this case, it's an even number. I'm going to divide it by 2. I get 2 and 12. Well, 2 is a prime factor, is a prime number, but 12 is not. I can keep dividing it out. So let's do 3 times 4. All right, well, I can still keep dividing it out. 2 divided by 2. 2 times 2. Okay, so now I have the prime factor 2 times 3 times 2 times 2. So what this essentially is saying is I have under the square root 2 times 3 times 2 times 2. If you were to multiply all of those together, 2 times 3 is 6 times 2 is 12 times 2 is 24. Now some of you may be saying, well, what if I decided to do it a different way? Because 24 has more than one type of factor. Well, let's look at a different way and see if we get the same answer. All right, so what if I decided I was going to do 4 times 6 instead of 2 times 12 to start with? All right, well, let's break that down. 4 is 2 times 2, right? And 6 is 2 times 3. Well, would you look at that? We still have 2 times 2 times 2 times 3. That looks pretty much the same as this one right here. So even if you choose different numbers to start with here, you should still end up getting the same number. All right, so let's go back to this. I'm now going to be looking for my pairs, okay? So you could either do it here, right, and look for your pairs, or if you write it all out like I did up here, you could look for your pairs right here. I see a pair of 2s. Those pair can come out and escape the jail. And now I'm still left with 2 times 3 because there's no pair with the other 2 and there's no pair with the other 3. But make sure that you are also simplifying the inside. So 2 times 3 is 6, and this is your final answer, okay? All right, let's look at a different one. 90, square root of 90. Well, on this one, 0, I don't know if it's an even number or not, but I like the number 0 because usually when I see this right here, I can divide it by 10. So let me divide it by 10. I'm going to go 10 divided by 90 is 9. And how can I break down 10? I have 10 makes 2 and 5, and 9 is 3 and 3. Oh, would you look at that? I have a nice pair of 3s here. So my 3s can escape jail, and I still have my jail here, and my 2 and my 5 have to stay underneath, okay? And so if I'm going to simplify that, I'm going to simplify the inside. This is my final answer, okay? Now, I know a common misconception is that, oh, what do we do with this number and this number? That's part of that, right? Well, no, it's not. Remember, we're trying to look for prime numbers. You're always going to look at the bottom of the tree, okay? So even if your tree is a little lopsided like this, right? These are all kind of down here. You're going to look for the very end of your path, okay? So I can only go this far, but with this one, I could keep going. Well, on this side, I could only go this far. I could keep going on this, and I found those two, okay? Let's do another example. Go ahead and go to the back side. All right, if you feel like you want to give this a try on your own, go ahead, pause the video, and come back and see how I did it. Okay, so I need a little help. I'm going to go to my factoring tree, and I'm going to look up number 32. All right, so there's a couple different ways I could do this. I could divide it out by, let's see, I could either do 2 and 16, or I could do 4 times 8. Well, I like the smaller numbers, and if you have your factor tree and you're able to do it, go with the numbers at the very bottom of the rows or the columns that you have. This one would be 4 times 8, okay? And so this is really easy, 2 times 2, right? And then I have 2 times 4. Now, I see a lot of people sometimes stop right there, but don't forget you can break 4 into more 2s. All right, so now let's look for pairs. I see a pair here. I see a pair here. What do we do with that? Well, what you're going to do is you're going to bring one pair out here, and you're going to bring another pair out. Now, what's left over? Okay, well, it's really easy to get lost in your factor tree. So make sure you're staying fairly neat, but look for your leftover prime number. So I have my prime number right here. Actually, I'm going to change that to 2. All right, so just like we simplified the inside before, we're now going to simplify the outside. 2 times 2 is 4, and I'm left with square root of 2. And this is my final answer. Okay, 4. Now 4 is a little trickier because the number is no longer on our factor pair cheat sheet. Okay, but remember what I said about the number 0. That's a hint. I can divide it by 10. So I'm going to go, if I do 10 times 12, or 120 divided by 10 is 12. All right, these are much easier numbers to manage, right? And I've got 2 times 6, and now I keep going and I break down 6 to 2 times 3. Now, here's another something I want to show you. Okay, well, I have this right here, right? 2 times 5 times 2 times 2 times 3. So that makes it a little easier to see your pair, right? But don't be afraid to do something like this. They do not have to be right next to each other to be considered a pair. All right, so my 2 will come outside, but what am I left over with inside? I still have 2 times 5 times 3, right? Well, let's simplify that. 2 times 5 is 10, times 3 is 30. This is our final answer. All right, go ahead and give 5, 6, 7, 8, 9, and 10 a try. Once you finish those, please bring them to Mr. G or myself, because we will mark this off as your homework for today, okay? But I want to show you one more example on the final page. So if you go here, let me clear this page here. Let's show you one more example. So in this case, we have a radical, and we already have a number on the outside right here. So we have 8 square root of 52. Well, oh my gosh, how am I going to mess with that one, right? Well, it's very simple. You just can't forget this is out here, but we're going to go ahead and just do our factor tree like we did before for the 52. So I'm going to go to my cheat sheet. I'm going to look at 52, and I say, ooh, this one's a little easy because I have 4 times 13. Those are the bottom numbers on my cheat sheet. And I can't do anything with 13 because 13 is a prime number, so that has to stay there. But I can break 4 down into 2, and look at that. There's my pair, right? So now I have 2 on the outside, but don't forget, I also have 8 on the outside, and I'm left over with 13, okay? So 13 will stay inside. Now, I want to simplify this 2 times 8 is 16, and I can leave my square root of 13. There's my final answer. All right, so now that you've seen all the different examples, I want you to go ahead and give the rest of these a try. Once you finish them again, turn them in, and then we will take a look at them and make sure we're on the right track. If you need some help, let us know.